Welcome students on the second part of the lecture on alkaloids, which is morphine. The contents of this lecture are: first, the skeleton of morphine; second is the constitution of morphol, an important compound which helps in determining the structure of morphine, and the synthesis of morphol. First of all, the carbon skeleton of morphine. In my previous lecture, we have dealt with the nature of nitrogen atom, the presence of double bond, the presence of phenolic OH, and the second one was the secondary alcoholic group, and the third oxygen was in the form of an ether linkage. The next part is the determination of the carbon skeleton of morphine, which is done by the following reaction. Morphine on zinc dust distillation gives an important compound, phenanthrene. The inference drawn from this reaction is that the phenanthrene nucleus is present in morphine. Next is the Hofmann exhaustive methylation. It is also one of the degradation method for determining the structure. Codeine forms codeine meth iodide. As we have dealt earlier also, the codeine is the methylated derivative of morphine. It forms codeine meth iodide, which on reaction with methyl iodide in heating with alkali gives alpha codimethine. As you can see here, this is a part of this morphine structure containing an methyl group. On doing exhaustive methylation process, the first step is the reaction with methyl iodide, and in the presence of silver hydroxide, it converts into a quaternary salt and methyl hydroxide. Quaternary salt is being formed, which on heating it undergoes cleavage here, converting it into a double bond formation is there, and this bond is cleaved from here, resulting in the formation of alpha codimethine. The inference drawn from this exhaustive methylation degradation method is that the nitrogen atom is present in the ring. Next is also the determination of the skeleton of morphine in process. Alpha codimethine isomerizes to beta codimethine on reaction with alkali. There is a series or the flow chart of the reactions conducted for determining the structure of morphine. Alpha codimethine on heating with alkali, it converts into beta codimethine. Both of these on reaction with methyl iodide and the reaction with followed by the hydrolysis with alkali, they form methyl morphinol is formed along with trimethylamine and ethylene. This methyl morphinol contains methoxy group and ether linkage, still retained in methyl morphinol. Methyl morphinol on reduction with sodium and alcohol, it converts into methyl morphol, which contains methoxy group and a phenolic group. Here methyl morphinol on reaction with HBr, it converts into morphinol. This means this methoxy group is converted into phenolic group and ether group is here. So methyl morphinol on treatment with HBr loses a methyl compound and converting it into phenolic group. Morphinol again on the reduction with sodium and methanol, it converts into morphol. Morphol is the compound containing two phenolic groups. This methyl morphol on treatment with HBr, it loses methoxy group, converts into phenolic group. So two phenolic groups are present in morphol. One phenolic group in methyl morphol and here there is no phenolic group, it is methoxy group and an ether linkage. So this is the flow chart, which from this flow chart the following inferences are drawn. Morphol is shown to be 3,4-dihydroxyphenanthrene by usual method of determination of structure. Morphol was found to be 3,4-dihydroxyphenanthrene. Here is the synthesis of the corresponding dimethyl derivative, that means dimethoxy morphol. Yeah, dimethyl morphol is here. Sorry, dimethoxy, no, it is dimethyl morphol. This is the synthesis of morphol. As you can see, the starting compounds which we have taken is 3,4-dimethoxy 2-nitrobenzaldehyde. Numbering is done from this group, aldehyde group 1, 2, 3, 4. 3,4-dimethoxy 2-nitrobenzaldehyde plus phenyl acetic acid. Sodium salt of phenyl acetic acid is taken in the presence of acetic anhydride. Here the reaction takes place, condensation, water molecules is removed and converting it to CH double bond C, COO. And this is 3,4-dimethoxy 2-nitro alpha phenyl cinnamic acid, C6H5CH double bond CH COH. So it is alpha phenyl cinnamic acid, which on first 3 steps, first is the reduction followed by reaction with sodium nitrite and sulfuric acid, and finally reduction with copper powder. This whole group is converted into this phenanthrene nucleus containing a carboxylic group. Nitro group is also removed from this. Next, on heating it, decarboxylation takes place, resulting in the formation of dimethyl morphol with containing 2 methyl groups. So this synthesis is very helpful in determining the structure of morphine, because as we know now that morphol is 3,4-dihydroxyphenanthrene, 3,4-1,2,3,4-dimethoxyphenanthrene. Since morphol is obtained from morphinol, as we have studied earlier also, morphol is obtained from, as you can see here, morphol is obtained from morphinol by reduction. Reduction of morphinol gives morphol. The morphinol will have the following structure, as you can see, 1 phenolic OH, 1 ether linkage, and on reduction it will convert into, this ether group will also convert into OH, resulting in the formation of morphol. Morphinol on hydrolysis with KOH, this OH converts into this phenolic OH, and here 3 hydroxyl groups are present in morphinol when it is hydrolyzed with KOH. The 1, 2, 3, 4, 5. 3,4,5 trihydroxyphenanthrene is obtained when morphinol is treated with KOH. A third hydroxyl group has entered here at position 5. This reveals that an ether linkage is present in morphinol. The inferences drawn from this is that the structure of morphinol establishes the position of 2 of the 3 oxygen atoms of morphine. One is at 3rd position and the second is the ether linkage between C4 and C5. Next is the how to determine the nature of the 3rd oxygen atom or the position of the 3rd oxygen atom. We have already studied the nature of this is that ether linkage, and there one more hydroxyl group is left to be revealed. Codeine meth iodide and codenone meth iodide on heating separately with a mixture of acetic anhydride and sodium acetate gives the following products. As you can see here, codeine methiodide on treatment with acetic anhydride and sodium acetate, it converts into 1,2,3,3-methoxy 4-acetoxyphenanthine plus ethanol diamine alcohol is formed. Ethane dimethylamine NN dimethyl ethanol is formed. Codenone methiodide, similarly on treatment with acetic anhydride and sodium acetate, it converts into 3-methoxy 4 and 6. There is one more position at the 6th position, 4 and 6 diacetoxyphenanthine is obtained along with the NN dimethyl aminoethanol. So these are the products which are obtained when codeine methiodide or codenone methiodide is treated with acetic anhydride and sodium acetate. The inferences drawn from this reaction is, first, you can see the presence of additional acetoxyl group in position 6 in the latter indicates that in the former, secondary alcoholic group is lost as water molecule during hydrogenation or to the aromatic product. As you can see here, this additional acetoxy group is present. This means that the secondary in the former, the secondary alcoholic group is lost as water molecule during dehydrogenation to the aromatic product. Here, from here, this additional acetoxy group has been removed during hydrogenation. In the latter, the ketonic group enolizes and hence appear as acetoxy group in the final product. In ketone, this ketonic group enolizes and hence appear as acetoxy group in the final product. This is the only difference between codeine methiodide and codenone methiodide. One acetoxy group only. Rest is the same. So we have determined the position of all the 3 oxygen functionalities. One is the phenolic oxygen at C3. The ether linkage is between C4 and C5. The ether linkage is between C4 and C5, and the secondary alcoholic group is at position C6 of phenanthine with the help of this reaction codeine methiodide and codenone methiodide. Now you can see the three position of 3 hydro OH groups. We have all determined all the 3. One is at this 3rd position. The second is in the form of ether linkage at C4 and C5, and the third one is at C6 position, which is secondary alcoholic nature. The rest of the structure determination we will deal in the next lecture. Thank you.